Great. It's November 11th. I'm sorry. It's November 4th or 5th, depending on what continent you're on. We're doing Buckminster Fuller's Critical Path, and we're going to continue our reading. John, how are you feeling? And what do you expect to get out of today?
Feeling good. It's a little cooler today. Yesterday was quite hot, about 35, 36 degrees, and quite windy, very dry, hot. Not good fire weather. This morning, about 26, 27, a bit cooler, and again had a walk in the park, which is always enjoyable. So I'm feeling good, feeling ready to learn a bit more, and hope to leave today's call with a better understanding of Bucky and a better understanding of my part in the world and what's happening in the world. Not much to ask for. So, Anne, how do you feel and what do you hope to take out of today?
Okay. Hello, everybody. I'm, as usual, glad to be here and looking forward, as usual, to what we're going to be discussing today. Maybe a bit of updates as well. I'll have to leave at about 12:50, heading down to Kuala Lumpur, which is about 45 minutes drive away. One of my little students, she's 10 years old, and she has just written a book, and she's launching it today. She wrote a book for adults. Okay, and she's launching it today, and she's going to be on the Malaysian Book of Records for being the youngest to publish. So looking forward to that one. And also, I will be away for one Sunday, next week. And I think, Steve, Wednesdays I won't be around I'll see if I can join this Wednesday, but if not, then I'll be out for 2 Wednesdays. I'm heading to Amsterdam and then the UK, so it's a long trip, but quite excited about that one. Okay, so looking forward to today. And Manu, how do you feel and what do you expect to take away today?
I feel good. I'm happy that we are 5 today, and as diverse as it can be. Richard in Hawaii, Steve in the US, me in South Africa, and then Australia also being here. That's quite diverse and representative sample of this world that we try to kind of build. So what I left last week was something that was really, really powerful. That was principles are eternal, special case interactions of a principle are eternal. Special case interaction of principle are temporal and brain apprehensible, because in pure principle, we have time. In pure principle, which is simply the principle of potentially different relative frequencies and not the beginnings and endings. Relative frequencies. And then there was a word teleological, and then we say teleology is very, very different from Machiavellism. And then we talk about boundary space, flow, and lag. And then we also talk about building instruments to extend our senses. So those were the things that I took away from last weekend. And I think that they apply so much into what we do in life and help us to the most extent possible. And that's what I expect, that we continue on kind of exposing these things to our apprehension and comprehension in order to apply in a better way we can. So, Richard, how do you feel? What do you expect?
Oh, I feel pretty good and pretty excited, just having come off a weekend of celebrating the 40th anniversary of our LivingWorks company. We had visitors from Singapore, Australia, Canada, the United States, Norway, England, Wales, Scotland, and Ireland. So it was really quite a weekend to have that many people there. And my good colleague from Perth, I'd met her the week before in another conference in Newfoundland, and she said that one of the things she wanted to have happen when she was in Calgary was to see snow for the first time. And we got one of our first big winter snowstorms the week she arrived.
Oh,
So she's totally elated that that she's taking back that memory to Perth.
wonderful.
So, and I'm here in Maui thinking about the temperature, which has been very warm, but since I'm in the United States, I have to talk in terms of 88 to 90 degrees and not the metric degrees that John was just talking about. So anyway, I'm hoping to get more sort of Hawaiian kind of insight into Bucky and Critical Path. And of course, as we all know, that this is the 40th anniversary of his death in July of 1983, and in December, it'll be the 40th anniversary of the Buckminster Fuller Institute, which is going to have some celebratory events happening next month.
Cool.
So back to you, Steve, and how are you feeling and what you are hoping to get out of today's session?
Well, thank you very much. It's just really exciting to see this participation. We're a small group, but we're a mighty group. And I just think it's just marvelous, Anne, that you have a 10-year-old. What grade is she in?
Grade 4.
Grade 4. And she's 10 years old?
Yes.
I have a great grandson who's 10 years old. And is this, wow, this girl, my grandson couldn't sit down and write 3 paragraphs, even though he's in a good reading group. I do have a granddaughter who probably around that age was pretty prolific, but she's on the spectrum. She's Asperger's syndrome on the spectrum. And so she was doing graphic novels at a very, very early age, but they didn't all make sense. And to put them, there wasn't any significance. So really, congratulations.
Thank you.
Yeah. And Richard, to see you celebrating 40 years of a business enterprise, a socially significant enterprise dealing with human beings and working to use general principles as a foundation for what you're doing. You guys are just real inspirations for me. I was talking with my daughter. I had my son-in-law is turning 50 today, and I was talking with my daughter, and I talked about, I'm writing this book, and I'm using what I would call general principles, and this idea that there are the way energy moves. It's significant to understand the way energy moves. Everything is energy. So the events that I'm seeing, the phenomena that I'm seeing, are just really manifestations of energy, and how my brain perceives and stores that information is one thing, and then how I can use my mind to intuit the significance and the interrelationships of those phenomena. I was kind of talking to her about, I'm writing this book on extreme mindfulness, and I'd like to communicate that. And, she said, well, that's what you taught us. You were teaching us all that stuff our whole lives. You're using different words now. And I thought that was really, really cool. I noticed that, the songs that I thought were so cool in the 60s and in the 50s, well, a lot of them were just party songs and raucous, good, fun music. But there were certain songs that had real significance. And I find the words in those songs have significance today, that somehow in my life, there were some guiding principles. There was some kind of basic energy. And so I resonated with some events. I'm finding new words. I really appreciate that I have Bucky to kind of look at things in a more engineering, architectural, system, organizational way. And that's really cool. But I find that I've been on that track, you know, for better or for worse, successfully and unsuccessfully my whole life. And I'm really grateful for that. And my daughter sharing that with me was touching and profound. And we went back and we reviewed, here comes Richard again. And we went back and we reviewed, she just told me about different events in her life where she saw those principles apply and how much it's helped her in her life. So that was really a wonderful thing. So I'm grateful to be here and to share with you guys and that you're all on. And Richard, you now have a camera. So I'm going to eliminate your other, shall I remove your other namesake here in the thing? Because it's still registered here. So I'm going to remove it. That should leave you here, and I'm not going to report you. Life is good. All right. So welcome. All right. So we're going to start with Bucky's at the bottom of page 162 in Critical Path. The very last paragraph of 162, it starts out right here, and then page 163 begins, and it continues from there. And I couldn't be more excited. So, and John, you're here, and Joe's not. If you would like to read for us,
I'm happy to read.
if you
yes,
want to
thank
get
you.
tired, if you get tired, you want someone else to share, just please open it up.
Okay, all right. Most of the important trend patternings are invisible. Ergo, their eventuations are unanticipated by society. Because of obstacles A, B, and C, most of the significant evolutionary trendings of human affairs cannot be detected and tuned in by people's self-coordinating brains. Few of their vital challenges are apprehended in time by human brains. When humans cannot see something approaching to destroy them, they do not get out of the way. Question: is there not an instrument that can inform humanity about its invisibly trending evolutionary challenges and do so in time to allow them to satisfactorily anticipate and cope with inexorable events? Yes, there is the geoscope, which can be swiftly realized both physically and metaphysically. Only for 6,000ths of its 3.5 million known years of presence on Earth has humanity sensed the shape, size, rotation, and sun orbiting rate of our planet in the solar system, as well as our Earth's relationship to other micro, macro universe events. Okay, just got to stop and wrap my head around that. Only human mind's capability to discover the only mathematically definable and employable physical laws of the everywhere and everywhen, non-simultaneously intertransforming, differently enduring, differently energized, independently episodic and overlapping, eternally regenerative scenario universe's laws, such as those of leverage, electromagnetics, and optics, has made possible humanity's additional discovery and participatory use of macro-micro universe information.
Let's stop right there and make sure we all have our head wrapped around this. That's obviously a typo that came up in the scanning of this thing here.
Yes.
I mean, this is Bucky, right? Only for 6/1000ths of its 3.5 million known years. I mean, this is like, that's just him, right? That's the way to do that. But for a very brief time, we have this capability to discover ourselves in relationship to the universe. I think that's what he's saying. Any other thoughts or words there?
I think he's saying first that things are things. Things are events. They're happening all the time. And they're happening in such a multitude. We only sense when we get hit. We only sense when we get hit. That is, we only sense in a lack. That's what he means.
Yeah.
Yes.
the lag. So yeah, because the brain stores it and then it's sitting there lagging behind, and life continues to move at a quick pace. And he's saying,
Yeah.
is there a way that the human brain can tune into what's actually happening instead of getting stuck in the lag?
Okay.
Is that
But
what
what
he's
is, yeah, what is say important is that in those events that are happening all the time, and very, very much so, very few of them with sense. That is what I hit with. But amongst them, there are some that are mortal to our kind. Right?
there are some
And
that are mortal?
yes,
Okay.
that if an asteroid hits this planet
Yeah.
undetected, what can we do? We finish in the form we are. Like it happened once, and dinosaurs disappeared and became birds that we
Yeah.
have today. So they didn't exist in that form anymore. So that's what you say. There is a possibility of cataclysm that can happen. It is small, but that possibility exists. Is there any way we can anticipate those?
Yeah.
That's the question. They say yes, that's geoscope. And the geoscope is actually the start of understanding of general principles
Cool.
and the inventory of them in a way that can be used to design. That's what it means, I think.
Well, I'm super sensitive these days to the concept of tensegrity. And so right away when he talks about the invisibility, I'm thinking tensegrity. And that's one of the few things that is still missing in many people's minds, to be able to see what you can't see. And when you realize that you can't see something, in order to see it, then you turn it into a thing. In other words, you turn it into a compression element instead of a tension element. And that sort of simultaneous, non-simultaneous sort of notion of universe is all about the flow, the flux, the constant motion that is going on that defies pre-20th century Western science that talks about static things, talks about building blocks, and talks about mostly compression things and not the tension interconnections. And so that's what I get out of that particular part of the reading almost right away, is and I just been reading some articles earlier today on principles of tensegrity and how they are applied in mathematical and engineering senses, but they're not applied in psychosocial kinds of senses. Very few people understand tensegrity in the social milieu of if you want, everyday living. So had I read that or heard it read 20 or so years ago, I would have been confused by all of the words that Bucky strings together into his sentences. Now it's a lot easier to sort of pull them out and try and understand them in the way in which we are reading and talking about them. So I'm complete on that sense.
Really good. I'm going to put in a little definition of tensegrity in the chat over here. I think you bring it up, and I don't think you were here last week, Richard. And last week he actually gave an example of tensegrity, and talked about if you take a 6-foot needle, a needle that's 6 feet long, and you work the ratio of how round it is. So the 6-foot long object is exactly the same ratio and size as a needle that's 1.5 inches long. The needle that's 1.5 inches long will float. If you put it in the water just right, it floats, where the 6-foot needle won't float at all. And which blew my mind. And I had to do some Wikipedia study on that to figure out exactly what he was talking about. But the idea was that the surface tension on the water will support that small needle. And there's not enough surface tension with a 6-foot needle. And so this idea of tensegrity is really powerful. And in the Grunch book, I got this definition: tensegrity, the continuous tension / discontinuous compression. So it's tension and compression, or expansion, I think, and compression. Structuring principle of universe. Stars not touching planets, electrons not touching their atomic nuclei, introduced to the planet Earth to replace the continuous compression. Oh, geez. I get frustrated when my computer doesn't. There it is. Replaced the continuously compression, secondarily tensioned structuring in the present world around engineering theory. And this idea of having tensegrity in personal relationships, and the fact that you would, for 40 years, be working on that principle of compression and, and tension, of expansion, contraction, this tensegrity is profound for me. So I just think it's really cool. Any other thoughts? Or I kind of went off on my needle thing, and my brain is still over in the needle and stuff. But any other thoughts on this before we continue?
I want to share something.
Cool.
Is that we can only act in compression, right?
We can only
Because-
what with compression?
Okay. Energy flows, energy always flows,
Sure.
right? So it's continuous flowing.
Right.
We can only act in compression and intermittently, discontinuously. We build structure to act in compression. Whatever we do in terms of orderly is to introduce temporal compression. But by doing that, what do we exactly do? By discontinuously building compression, what do we create, Steve?
Well, I would say you're talking about we're talking about anti-entropic
What do we create?
stuff.
We
Tension.
create music. We create music.
Okay, I create music, but
We
also
create music.
buildings.
We create waves.
Yeah, but we also create
A
buildings.
wave, yes, a wave is created by a repeated discontinuation of something.
Yeah,
You discontinue it, stop, move it, it flows.
Yeah.
We create music.
yeah, like the water's coming out of the mountains, we create an irrigation ditch, and now we can water the ground.
And what is it? Electromagnetic waves.
Okay,
If
everything is energy. E equals MC
yes.
squared.
So my point is that if the compression were not discontinued,
Yeah,
there wouldn't be music.
okay,
There wouldn't be music. So you need that. That is the tango of life,
yeah,
of or whatever that is happening.
Yeah.
Continuous tension that is going away,
yeah,
and discontinuous compression trying to stop it.
yeah.
And by doing those things together, you create music. And the music of life, the electromagnetic wave, whatever that we've been talking about, that character that is so intimate, that is so intimately meshed to play the symphony of life.
Well, that's the whole thing. You see, the strings on a guitar are easy to see the tension. But the strings between us or human beings
Yeah.
Cannot be seen in the same way you see the strings of the guitar.
Right.
Mm.
So what he says is, I think, really in tune musically and life-wise with the principles of tensegrity. What most of us miss is being able to see the strings in a real sense, because you can only see the relationships, the strings between people, in a metaphorical way. So you have to create the idea that we are connected by a string or something. Until I think that's one of the reasons why tensegrity is not well understood in a human relation sense, because you can't see the relationships.
I totally agree.
And that's why structuring is always local. Structuring is always local. And the boundary concept.
Yeah.
In order to
Well,
have structure, you
there
first
are
need a boundary.
there are non-local macro systems that have structure, but I can't experience those because I'm trapped in my local universe.
Yeah.
Cool. You guys, I just think this is really critical. And there's another concept that he brings up in the writing over here. And the concept that he brings up in the writing here is where he talks about macro, micro. Whoops, where's the book? Whoops, that's my other stuff. I'm doing research on the background here. Here he is right here. He says, possibility of human additional discovery and participation, use of macro, micro universe information. And it's taken me a long time to grok this concept of macro, micro universe. And to me, the thing that was the most mind-blowing and most illuminating to me was Bucky's concepts of the circles of irrelevancy. And that here we have in the blue area there, we've got conceptually definite. But then as I move outward, I move towards macro. And he says up here is that finite withoutness, non-simultaneously, non-synchronously tunable. And Richard used the word tuning, and Mano used the concept of music as a metaphor, which is perfect because Bucky was all into tuning into reality. And then between this whiteness of this withoutness of non-simultaneous, non-synchronously tunable, we have this twilight zone of almost relevant, what we can almost tune into. That's macro reality. We're in the blue circle, and I put that little red dot in there showing the idea of compression and expansion. We sit in that little blue red circle with this tensegrity going on between the macro and the micro. And of course, the micro is everything to the left of the blue circle or towards the center of the concentric circles. And the macro is everything moving to the right of that red circle or outward towards the withoutness. And so, and I did this because I really pondered this. And so actually, I'm a 4-dimensional being. This little red circle right here, which is me in the finite, conceptually, tunably synchronous. See down here at the bottom of the blue, it says tunably synchronous, approximate simultaneity. And so, but in reality, I'm actually everywhere in there. And then inside of me is macro reality. Inside the red circle is micro reality, and outside the red circle is macro reality. And so, and this is looking at a human being from a 4-dimensional perspective. Because I have to see inside of me and outside of me. I'm a 3D thing. And inside of me is 4D and outside of me is 4D. So anyway, this is the macro micro, what he talked about here when he brought up his macro micro universe information. So some things are so small, they're so finite, but they're non-conceptual. They're just too small to conceive. Like, for example, anything below infrared light. Let's come back over here and we'll take a look, because the other parallel here is the electromagnetic spectrum. And so what we have here is it's going to show up here. What we have here is, gee, I hope I'm hitting the right button. I'm having trouble. There we go. Okay, so visible light is that little tiny slot right there, right where the sun is. If you see the sun about below column 5. there's visible light. Everything below that is moving slowly. We cannot see it unless we have tools to see it. And everything above there is moving so quickly, we can't see it unless we have tools to see it. In other words, we need machines to help us tune in to this reality. If it were not for our microscopes, lenses and electronic and other things, if it weren't for our telescopes, electronic and optical, we would see, like right now, visible light represents less than 1% of the electromagnetic spectrum. So, this is the micro is everything up there. It's small, too small to tune into, and the macro is everything too big to tune into. Down here at the very bottom, we have extremely low frequencies. These frequencies are as tall as the Empire State Building. And if it gets bigger than the Empire State Building, we can't even, they're measuring gravity waves, and they're almost flat. And the way they measure those is by having electronic telescopes on opposite ends of the planet. And as the planet rotates around the sun, they're constantly measuring these things, and the computers have to put them together. We're actually able to measure gravity waves from the beginning of the universe that are so flat because they're so huge. They look flat, but they're not. So I don't know. This is the macro micro that he's talking about. I wanted to share that because to me, it's taken me 3 or 4 years to understand this stuff. And I thought it would be wonderful to hit that at this point. Any other comments or questions on anything anybody said so far?
Well, I think you've just done something that in a very simple kind of way says, there's the difference between Newtonian pre-20th century science that tried to see everything as visible or solid or a thing, in other words, a compression element, and quantum sciences in the 20th century and beyond that see everything as in relationships. And we're 125 years into post-19th century, and most people have no idea what you just were talking about in terms of what's visible and what isn't. And it's really a shame in my mind that our young students today are not taught about these big discoveries in the 20th century that shifted us from Newtonian to quantum kinds of understandings of how everything works.
Wonderful. I want to point out, I took it one step further, and I took our electromagnetic spectrum, that little, I don't know if you can see right there, it says visible light. That represents less than 1% of the electromagnetic spectrum. And then I just used my imagination. I used my mind and I intuited. I said, well, what if the electromagnetic spectrum, which is what we can experience now with all of our tools, what we can tune into, that which is tunably relevant, what if that electromagnetic spectrum represents less than 1% of all the energy in the universe? So that what I as a human being perceives is less than 1% of less than 1% of reality, the way that it really is. And there are guys like Donald Hoffman and Stephen Wolfram who are talking about the fact that space-time, as we know it, the rules of space-time, the rules of quantum mechanics and astrophysics break down and don't apply at anything that's way too fast or way too slow. And actually, Donald Hoffman has given a mathematical thing. I think he said it's like 1 to the 80th or something, or 1 to the minus 43rd. Anything smaller than 1 to the minus 43rd, quantum mechanics breaks down. They can't read anything that's faster than that or slower than that. And the same thing with time. That time works until a certain point. Like I think he said it's like 10 to the minus 43. When we get that small, time doesn't work. Here comes Joe. And so they're now looking at, okay, if all of our rules of general relativity and specific relativity and all of our rules about quantum mechanics don't reveal anything more about the nature of the universe, what is the universe? And guys like Donald Hoffman and Stephen Wolfram are talking about the nature of energy in the as it may really exist. And in fact, Donald Hoffman and Stephen Wolfram are talking about the amplituhedron. They're talking about polytopes, geometric shapes that are the funnels on which the energy that we experience as human being is funneling, which goes right back to Bucky's jitterbug. I mean, it's so amazing that as I listen to Stephen Wolfram and Donald Hoffman and these new guys talking about the nature of reality, that human perception is an artifact, that space-time is an artifact of human perception, that humans did not evolve to see reality in any way, and they prove it. That if humans were seeing reality the way it really was, we'd be eaten by the tiger that's in front of us. So our biological entities had to evolve to protect us from tigers and from cars speeding down the freeway. But they don't tell us about the nature of reality, the nature of, you know, things that are not so tunable. Anyway, I'm rambling. I hope that was I hope that's helpful and wonderful. And any other comments or questions before we go ahead? Joe, welcome. Go ahead, Manu.
What does it mean then practically?
Are you asking a rhetorical question? Usually you answer.
No, I'm serious. Practically, what does it? In my opinion, not to waste time, let me just say what I think.
Okay.
In practice, it means that we have to accept the general principle that there is an eternally regenerative universe. We have to accept that, we have to acknowledge it, we have to accept that our experience requires boundaries. We have to accept that in order to build that experience, we have to be accepting the principle that the boundary will be revised all the time.
That the boundary will be what all the time?
Revised.
Revised.
Revised, depending on our senses. You remember this?
That's right.
The boundary will be revised all the time. Change.
Yeah.
Right?
Right.
So in that amplituhedron, our locality has some boundaries.
Right.
And we have to internally accept that, you know, if what we measure does not is not in sync
right.
with what it is we sense as a general principle, we got to change the boundary.
Right.
We got to test anew. So those are in practical what we repeat every day when you see people that train and do things that, you know, and even building principle that do the best with what you have.
Right.
But be open to change. Because the best of what you have doesn't mean that it's dogmatically true. It just means that you accept the reality that what you have at that time is the best you can, and you do the best with.
Right.
And time is intimately linked to the boundary.
Absolutely correct.
If there were no boundary, there was no time.
Exactly.
And that's what Wolfram was saying, is that below a certain sensitivity, time breaks down because it requires boundary. And boundary is imposed by our sensitivity.
Right.
What can we sense in this reality as qubits?
Right on. And Richard's paradigm of inviting people in a psychological, social psychological context, geez, correct me, Richard, if I'm saying something wrong, but using the tetrahedron as a model, saying, okay, you know, talking to a client or talking to another person, you know, you've got two people going on. How many relationships do you see here? Or there are three people. How many relationships do you see here? And using the tetrahedron, the n² - 2, or n² - n divided by 2, saying, okay, there's more to this problem than you're looking at. And he uses the tetrahedron to invite people to see that the boundary that they perceive is not real. That there's more to the picture than they see. Richard, did I talk about what you do correctly?
Yes.
Wonderful. You don't want to add any more to it?
No, well, yes, in the sense of if you're coming from the Newtonian building blocks idea,
Right.
in the tetrahedron model, you would be asking about the nodes, the corners.
Exactly. Right.
And so you'd be asking about you and basically much of what we do here even is that we would ask, how are you feeling? And in the quantum side of things, you would be asking about the relationships between.
Right.
So it would be like, how is the relationship between one or more of us at a given moment, rather than the focus on the you, which is focused on the compression element. And that's the beauty of using the model with others, because you can then say, here's node 1, 2, 3, 4 represents something. So I could take 4 of us and say each corner is made up of one of our names. And then I would say, so what's the relationship between Steve and Richard, or between Anne and John, or between Manu and where are we?
Yeah.
Joe, for example.
Yeah.
And then we would switch it and say, so so how's the relationship between Anne and Manu, being Joe and Steve, and so you would get a whole different kind of experience starting to be talked about in terms of the relationship between all the parties that are together in a particular event.
Yeah.
And Richard, while you were talking, I took the liberty of throwing the cosmography chart of n squared minus n divided by 2. And actually here is the, down the left column, number of events. When you said there are nodes or corners in the tetrahedron, and you described one of those nodes or corners as a U, Bucky would say those are an event or a happening. And
Right.
now we have the dots representing the you-ness and the me-ness and the event and the happening and that which the brain perceives. And then we have the lines between those dots, which are they're only revealed by the mind. The brain can't see those. We've got to intuit them. We've got to talk about them. We've got to discuss them. And so it goes all the way down to 7 nodes on the chart here, if you remember the cosmography chart.
Yeah.
And then the n squared minus n over 2, that column, the third column, shows the number of relationships. If there's only one node, there's no relationship. There's no interrelationship. If there are 2 nodes, there's one interrelationship. And actually, there's a concave and a convex. So actually, because 1 is a minimum of 2. But then if there are 3 nodes, we have 3 interrelationships. Then if we have 4 nodes, suddenly there are freaking 6 interrelationships. And 5 nodes, there are 10. And 6 nodes, there are 15. So the more people we put together into the conversation, the more complicated things get.
Yeah, for me, I'm now using the word complex.
Complex, yeah.
The more complex things, complicated, unfortunately, has taken on a negative sort of meaning for most of us.
Agreed.
And it sort of scares us if it's too complicated.
Right.
One of the other beauties about the complexity of what you've just described is that the more you add nodes and go out, the greater the increase in the complexity or the relationships in between. And if it gets out a certain distance, then it becomes complicated or overwhelming. And Bucky's idea of being able to divide at the midpoints of a triangle allows you in a fractal sense to then enfold them back. And that way you actually get the notion of being able to unfold complexity out to whatever boundary you're still capable of appreciating or understanding, or if it gets too much, you can enfold it all the way back. And a minimum whole system concept, you will only enfold them back to the minimum whole system. In other words, to a minimum of 4.
Right on. While you were talking, I showed a one artist rendition of an amplituhedron. That's on the screen right now. And then I also showed just briefly a star tetrahedron or a double tetrahedron broken out
Right.
into the multiple octahedra. The relationship, the more vectors, the more nodes, and vector was the wrong word because there's a vector between the nodes as well. But the more
vertexes,
the more vertexes, exactly, vertexes, the more corners, nodes, vertexes, the more interrelationships there are and the more complicated it gets.
Right.
Very cool. Wonderful. Any other comments or questions before we continue to read?
Just 2 comments.
Okay.
The first comment is that it's actually complexity square, because you always, whatever structure that you have, we've been talking about Arginote, you always have to recognize that there is the otherness. What I know is so small in comparison to what I don't know.
Yeah.
That is a constant fuel. So it, you know, it's and it's on its own, it sustains the principle of work, because we always have to move to work. That's the principle of moving energy. You know, it's structured here, but there's otherness.
Right.
We're designing something. There is the back. You know, there is what you call pollution, or the back burner. All these things come to play. That is one. The second thing that is very important, that you show the breaking out of a double tetrahedron sieve, is this one. Is that it is sufficient in order to structure and to understand the structural universe. Only 2 divisions are required. The first derivation that gives the different tetrahedra, if you take, I don't have one here, I will have shown it. You divide 4 tetrahedra, and then you see to do a second derivation, you have the octahedron. So you can represent, in terms of analysis, everything that we sense in terms of combination, what you call a linear combination in mathematics between tetrahedron and octahedron. That will always give you the structural world plus the residual, that is the rest that we don't know. Do you get me?
I think so, at least in part, my friend.
The whole equal the structure plus the unknown. That is an equation that we have. The whole is what we can structure plus the unknown.
Exactly right.
And the structure can always be written as a linear combination, that is the weighted combination of tetrahedra and octahedra. That is, your structure is A times tetrahedron plus B times octahedra. It gives you the whole structure. So our design can be expressed rationally, and that's what Bucky's theory is that it doesn't say that the very complicated pi and exponential and all of these irrational numbers don't exist. But it says in 99.99% cases, you can use mathematically ratios of things that are measurable to build a universe that is anti-entropic, to build a structure that is anti-entropic. Do you understand what I'm trying to say?
I think so.
Yes.
Everybody else have comments? Go ahead.
Pi is very scary. You know, you want to teach mathematics to a guy, a child and you teach him pi, it is very scary to say pi.
Right.
But if you do it in terms of relationship between, you just say is a radius, is the ratio some kind of ratio of radius divided by the circumferences. You understand? That is pi. But it wasn't expressed into a scary 3.1411, all of these series of numbers that go to infinite. You express it into something that is palpable, that is sensitive. Fred used to call it what do you call it? Sensitive geometry? What was he calling it? Fred. You
I
remember Fred?
But I only talked to Fred like 3 or 4 or 5 times before.
Tactile, no, he called it tactile geometry. Tactile.
Tactile.
Yes.
Cool.
Yep.
Any other comments or questions? All right, cool. You guys, and it comes back to this. I just think that what I've learned from Bucky, this idea of the macro micro, that things are outside of me and inside of me, that they're way too big to see and they're way too small to see. And of course, what's way too small is also outside of me, but it's inside of me. And I just think that's so powerful because, Einstein taught the theory of relativity says that every human being, every observer is in the center of the universe. And I think Bucky's saying the same thing, that universe is local to each individual perspective. And I think those are powerful concepts. Okay, not to beat the drum too much. And I love the fact that John has a tetrahedron in his logo of Butler's Lawyers.
I do, yes.
Yeah, and how long has that been there? Probably for a long time, huh?
Yes, I played with it. I was first exposed to Bucky in 1990. So that's 33 years ago now. And I played with it for a while. We established our current firm in January 1994. So we're coming up for 30 years in January. And I think we've had the tetrahedron around for most of the last 30 years.
Wow. So you and
the building block of the universe, the building block of the universe.
Building block of the universe. I'm gonna go ahead and I don't know that everybody can see that, and certainly the ones that are on the recording can't see it. So I'm going to share. There's that's Butler's Lawyers logo right there.
Mm-hmm.
So we have Richard's been doing it for 40 years, and you've been doing it for 30 years, and I'm just now catching up with you. I'm so excited. Oh, wait, you're showing a picture there too, John. Let me make sure I get that. Yeah, Butler's
it's a more subtle tetrahedron on a business card.
Oh, that's on your business card. Hold it up a little bit higher. Good. I'm going to take a screenshot of that. Okay, good. And I'll just stick it in. Okay, everybody can see it now watching the thing. Your personal law firm. Love it. What does the circle represent to you?
Well, we know there are no circles in nature, but that's just to enclose the tetrahedron.
Yeah.
Boundary.
The boundary. Yeah. To represent the fact of the macro and the micro. Absolutely. The circle represents macro and micro simultaneously. Wonderful. I'm just honored to be hanging out with you folks. Okay. Any other comments or questions?
Just one thing. When you put the wireframe tetrahedron inside a circle like that, and you see it two-dimensionally, if you can then picture curving out all 6 of the edges, you will end up with a sphere.
Yeah.
And so what's neat about that is that we show it, or like John has shown it, in a 2-dimensional sort of format, but if you did it 3-dimensionally and pushed out the edges into curves, you would form a full sphere, a 3-dimensional, if you want, sphere. And so that's the other exciting thing about that idea of the tetrahedron, either flat, laid down and see 4 triangles, or up and you see it in its holistic way. depending on how people comprehend, you can lay it down flat so they can understand it two-dimensionally, or you can display it holistically for those who understand holism. And you can go back and forth rather than treating them as opposites. They're one and the same thing.
Yeah.
Just
Excellent,
a
Richard.
different dimension.
Yeah. And another point is that when we talk about boundary, we always forget, we always talk about the micro boundary, the outward boundary. See, we are in between. So when you talk about boundary, is that twilight outward and twilight inward.
Right on. When
You
this
see
comes
what I
back-
mean? But
this
we
is-
almost never, we almost in our representation, when we talk about boundary, we just see the twilight outward. There is another one inward that we have to talk about, because conceptually, we are in between things,
Exactly.
constantly in between.
Beautiful.
Um, Okay, I have a question actually for John. Okay,
Yes.
because okay, I've been getting over the years, yeah, I've been getting a lot of lawyers, uh, those who have graduated and they actually qualified to practice law, or they've gone into the law practices and all that, but they've stepped out. I cannot tell you how many I can count in my school. They've decided no, it's not for them. They don't want to be a part of it anymore. And some of the things they shared with me, I mean, we see it on TV and so on, but on the ground, what they went through with it, it was completely what they didn't expect law to be. Yeah, they were looking out there to get justice for people and so on. So, John, because you've been doing law for the past 30, you've been doing law for a long time, right? And then also, you've been studying Buckminster for the past 33 years now, yeah? So how do you, what do you do to like kind of pull in this, what Bucky talks about, Hughes and living re and all that into the practice of law? Because we've been talking a lot about the science aspect, yes, and we've been also been sharing a lot about the education side. It just suddenly occurred to me that I would really love to know how you apply it for.
All right.
law.
Okay. So in summary, I think that the majority of human beings are driven by ego rather than consciousness, which is why we have more focus on killing re than living re.
Mhm.
So we are more driven by fear than by love. And the origin of law is that it's a more civilized way to resolve disputes than the bigger one with the bigger club killing the weaker one without a club. So the law is intended to do a number of things, but one of them is primarily resolve disputes, to provide for people's rights, to document and protect those rights, and to resolve disputes. And that's everything down to making your will, so that you have a lawyer explain to you how you can use a will to achieve what you want beyond your life. And the law creates rights. It gives people rights. It is intended to protect those rights. That's the theory. We have lawyers who are an embarrassment to good lawyers. We have lawyers who are primarily motivated by earning a good living or because their parents wanted to have a child who's a lawyer. And so they're trying to please their parents when they do law. Many of them then try law and decide it's not their personal passion, not what they really want to do. There are some great lawyers who are passionate people driven by a desire to contribute to a better world, and they achieve that in many ways. I still get a lot of satisfaction when I can assist somebody, when I can assist them to resolve a dispute. And we've made changes. So, for example, if we talk about family law and relationship breakdown, there's a much greater emphasis on using mediation, alternative dispute resolution, to resolve disputes earlier with less conflict and less expense. And that works in the majority of cases. There's been a huge, I mean, I'm old enough to remember the Matrimonial Causes Act of 1959 in Australia, which was all about proving that the other party to the marriage was the guilty party because you did a lot better at the end of the marriage if the court thought the other party was the guilty one. So it was a system based on fault. And the not guilty one should be rewarded and the guilty one should be punished. That's an act of parliament that governed marriage breakdown in Australia from 1959. 1976, we brought in the Family Law Act, which supposedly abolished fault, and it did to a significant degree. So there has been evolution and change and improvement in many areas of law, but one of the huge issues we've got as a society in Australia at the moment is family and domestic violence. You know, we recently actually in Western Australia in the last couple of weeks had a female lawyer murdered by her partner. And that's a fairly extreme example of family and domestic violence in our faces, because most of the lawyers in Perth knew her. So I'm going to jump now to Eckhart Tolle, who says, you know, somebody asked him following the attack on the Twin Towers, is the world becoming, you know, worse or better? He said both. He said people are moving to the extremes. You know, we've got terrorists who are prepared to fly a plane into a building with the intention of killing as many people as possible, with other people working on consciousness and becoming more evolved human beings and contributing to a better world. He said the middle ground is disappearing. If we look at politics in the United States, I think you could probably say the same thing. I mean, I'm horrified by what I read about politics in the United States. It's becoming more extreme. The Republicans are becoming more extreme. People are polarizing. I mean, Donald Trump's supporters believe everything he tells them, and no matter how much he breaks the law, no matter how criminal his actions, no matter how much he's a walking example of a huge ego. And somebody I know very well described him as a 2-year-old constantly throwing 2-year-old temper tantrums. But the system is flawed in the US. We've got a system of government where they've constantly got to get approval to even fund the public service. They're now on the razor's edge again, and there are extreme Republicans. The last Speaker of the House was thrown out by his peers because he wasn't extreme enough. There are concerns the current new Speaker is going to be even more extreme and will damage the country. And apparently many extreme Republicans don't give a damn if they damage the country. It's not about living it's not about, you know, improving the lot of every human being, which is what Bucky constantly worked towards and studied for and intended to be the outcome of his work. His work was designed to improve, you know, the living standard, because he knew that would help the planet. So it's a challenging world. And going back to the law, and if you look at the system in the United States as an extreme example of money and egos, clashes of the titans, no integrity, you know.
John, maybe the question thank you for that. Yeah, it's good to hear that. How then do you handle the ones that don't, you know, behave in like practice law without the integrity, you know, being whole and also like they'll do whatever it takes to win. So how do you deal with that? That's where I'm coming from, you know, to try and understand.
Well, we have, I mean, in day-to-day practice dealing with other lawyers, you know, there are some you can trust and some you can't trust, and some you can work cooperatively with to achieve a fair result for both parties, and others you can't. You know, we have our own watchdogs, we have our, you know, disciplinary bodies and otherwise. Some people just don't have, they don't demonstrate an understanding of what's appropriate behaviour.
Okay.
And some of them are no longer able to continue to practice law, some still survive in the shadows. So law is like every other occupation, every other profession. There are those who are good people doing their best to help those around them, and there are others who are ego-driven and really don't give a damn about other people. It's more obvious at times.
Let me jump in here, John. So what you're saying is that if we're going to use Bucky language, some people are able to tune in to realities that are more subtle and more cooperative and more compassionate, and others are not able to tune into that reality at all.
Yes, yes, yes.
And then you brought up, I think, because I want to push this inquiry a little bit further to Anne's question. You brought up the fact that there are these legalistic ways to solve problems or prove who's right and wrong. And what you guys did was you always, at least what I heard you say, was you tended to move towards arbitration, which would allow mediation, and you move towards mediation to resolve problems rather than just to prove who was right and who was wrong.
Yes.
Yeah. And that, to you, that tetrahedron represented that invitation to realize other points of view and to mediate rather than prosecute or make claims arbitrarily.
Yeah.
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 Is there any other, did you, and this is, I don't mean to be, did you, like Richard's been able to use this tetrahedron, actually used it in his relationship with clients and with the students. Do you recall ever becoming specifically aware consciously that your tetrahedral design was going to influence you a certain way, or just that the idea of just interrelationships are an important aspect of resolving issues between nodes?
I think it's more the latter.
Yeah. Yeah.
Yeah,
good.
what's wonderful about that too is that talking about family courts and family mediation, we've used the tetrahedron as a talking stick. So it triangulates what might be a dispute issue between two, triangulate it so that it becomes more stable and more easy to sort of talk through the issues through the talking stick. The other that's really interesting in connecting to John is that we started as a succession plan for our Living Works education program focused on suicide prevention. Back in 2009, we finally found the new owners that we were willing to go along with. They were tax lawyers who had reached a sort of the optimum in their legal sort of practice and switched over to our kind of work in order to add a different kind of meaning to their career path, which is and now I'm trying to convince them to really understand the tetrahedron. So I should actually call John in probably to give them a consultation on lawyer to lawyer talk.
That would be cool.
Love it.
Well,
Yeah, thank you very much, John.
Yeah.
Thanks, Ed.
And I want to jump in because I want to add the fact that, in my work, because I was on the ethics committee for the Board of Realtors for 3 years back about 35 years ago. And so I saw conflicts all the time between contractors and realtors and owners and potential buyers and potential sellers. I saw these conflicts all the time. And they wanted to, it's always easy to move to who's right and who's wrong and who should be punished. As John said, who should be punished and who should be rewarded. Well, I found out early on that there were two sides to everything and that nobody was usually either all right or all wrong, and that somebody stepped across the line at some point. So what I've done is I've learned to ask people when I hire employees or when I talk to when I'm looking at hiring an attorney. One thing I want to look at is their win-lose record. How many times have you litigated issues like this? And many attorneys will say, well, we're not litigation attorneys. And then I might say, well, how many times have you mediated issues like this? Oh, we don't mediate. Well, how many times, and you have to ask them questions like, when did you mediate an issue that could have gone into court, but it didn't go into court because you were able to mediate and find some mutually agreeable reality? I was going to say compromise, but there is no compromise. A mutually agreeable reality without going to court. And you have to ask these questions of employees. You have to ask them of potential contractors, attorneys, CPAs. If I don't get a good understanding of how they creatively solve problems, I don't care if they understand a tetrahedron. I want to know if they understood the interrelationships of the parties involved. So I'm using a tetrahedral metaphor, but what I'm inviting them to do is, okay, because most people never thought about it. How do you see these interrelationships? How do you mediate these interrelationships? And if an attorney or a prospective employee cannot give me an idea of what problem they solved and how they solved it, and the grounds they found for to be able to intermediate issues and resolve issues without conflicts, you know, I prioritize that when I'm hiring contractors or attorneys or employees.
Okay.
Because I understand the model. And I think, you know, you have to think like Richard, you know, okay, look, I'm looking for, there are 6 people involved in this thing. So 6 squared is 30, 6 times 6 is 36, minus 6 is 30, divided by 2. We have 15 potential relationships going on here. Let's identify what they are. And I would be thinking that in my head. So I'd sit down with people, okay, let's identify the interrelationships. And I'd start listing them. If we don't hit 15, I'm going to keep going. Because there's 15 interrelationships there at a minimum. And I'm using the formula, nobody else cares. But I want them to see all the elements in the game. Anyway, hope that was helpful. Manu put into the thing thoughts, words, actions, behaviors, patterns, habits, character, destiny. I love that.
Yep.
Integrity is a matter of character and transcends occupation. Those were thoughts that Manu put in. Okay, any other, boy, I love everybody sharing. I love the fact that we've only gotten 3 paragraphs in and we've like, to me, if everybody in the world got these concepts right here that we're talking about, macro, micro, tensegrity, you know, interrelationships, the idea of n squared minus n divided by 2. If everybody got that, and that was the basis for them looking at problem solving, whoa, would we have a better planet? Okay, any other comments or questions before we continue? I'm so grateful for everybody's patience and contributions. Okay, here we go. There's still time to read. Whoops.
Yeah.
I just love this chart, you guys. This is 4D reality. This is reality inside of me in micro and outside of me in macro. I meditated on that for months to come up with that. So I just really proud of that. Okay, here we go.
Love it.
Yeah, cool, Richard. Thank you. Hey,
Yes. Oh, what?
hang on a
That's
second.
where we're up to. That's where we're up to.
That's where we are. I just want to say I've double checked this, and this is exactly letter for letter what Bucky wrote in his book. This is not typos. So good luck, John. Okay.
He's being a Scot, it's Robbie Burns. Oh, wad some power the gifty gie us to see ourselves as others see us.
Yeah.
To facilitate humanity's comprehension of its present status in universe, what is needed is a sensorially tune-inable physical means of seeing ourselves as others see us. Poet Robert Burns' wish was partially fulfilled when, for the first time, Earthian humans standing on the moon took coloured moving pictures of our planet Earth exactly as seen from the moon and electromagnetically dispatched the pictures back to us on Earth to be seen over anybody's and everybody's properly tuned in television sets. Most people will say that if you want to get the best map of the whole world, use a globe. The bigger, the better. The trouble with a globe is that you cannot possibly see all the world displayed on it at any one time. The experimentally disclosed fact is that without revolving the library Earth globe, you cannot read the names identifying the geographical data of more than 1/4 of its surface at any one viewing. You may say the larger the globe, the more you can see of the world in any one viewing. If that were true, you could use the real Earth as your optimum globe. The fact is that the bigger the globe, the less of its surface data you can see and read at any one time. With a 12 or 16-inch globe, you can get the most information possible in any one viewing. This is approximately 1/4 of the Earth's surface. Because humans
Pause
want
right
to
there
see...
just for a second.
Okay.
I just had an epiphany because I've looked ahead, and if you guys are looking at your book, we're about to come upon a bunch of diagrams where Bucky starts describing reality in terms of circles, spheres, and triangles. and we're going to move into his Dymaxion map. And so he's going to start explaining this idea of spherical geometry and how it relates to triangles. And I just had an epiphany here that the Dymaxion map is a topological way to maintain dimensions in a representation of reality. In other words, and so I'm understanding topology in a different way. And rather than try to explain that, I just thought I thought I would share the epiphany and find out that that's where we are today. That's where I am. So maybe I'll talk about it more. Go ahead.
Interject there. There are two things. First of all, the Dymaxion map is much more accurate than the Mercator projection, which we were brought up with in school.
Yeah.
But the other thing is it gives you a very different view of the world. With the Mercator projection, you see these isolated continents with lots of ocean in between. With the Dymaxion map, you see the world as really one big island in the middle of the ocean. So it not only is a more accurate representation, it gives you a different view of the world. The world
Really?
is one rather than separated.
And we're going to
So-
see that Dymaxion map on page 169, and we're not going to get there tonight. So this conversation is going to be a beautiful introduction to next week's call. Any other comments or questions? Yeah, Manu,
Yeah. Yes.
go for it.
The whole is a tetrahedron or a double tetrahedron.
Okay.
Now, if you could squash time, that is, you could jump almost instantaneously between vertices of a tetrahedron. That's what to squash time. You understand what I'm saying?
Kind of.
At one time, at a time, you can only see from a vertex
I
a
see.
quarter of a tetrahedron.
I
One
see.
quarter, that's what they say.
That's right.
If you put yourself at the vertex of that
Yeah.
hole, you can only see one quarter. You can understand sensitively what I mean by the quarter.
Yeah.
Now, time is how fast or whatever the different vertices come to you in your position as an observer.
Right.
So if you quash them, that is, you are on the 4 vertices at the same time. Then you see the real representation of Earth as it is without interruption of time, of frequencies of occurrence. I think it's quite powerful here.
Okay. Okay, now, see, this is an invitation here because, and Manu, I'm just going to go with this. I agree with you if you're sitting outside of the double tetrahedron or outside of the tetrahedron or outside of the octahedron. If one moves to inside the octahedron, then one can see all of the faces outside at one time. If I'm outside the octahedron, I can only see one face at a time. If I'm inside, I can look and see it all. This is the essence of extreme mindfulness. This is the essence of the Buddha's enlightenment. This is the essence of Bucky's thing. Instead of being outside, move inside and take another look. There's another picture over here. Let's see if I can bring this up. And because if studying the Kabbalah tree of life and studying different kinds of cosmology. Oh, here, I wanted to bring this up. So this is the idea of the human being inside the octahedron. You'll see this octahedron is represented by the red lines. It looks distorted, but the only reason why it looks distorted is because of the perspective, in order to show the octahedron inside. So here's the human being inside the octahedron, observing the spherical nature of the universe. And this is the 7 directions in Native American mythology. It's in Hebrew mythology. It's in Egyptian mythology or cosmology, the 7 directions. And if one moves to the center, one gets a perfect balance of everything. Now, what Manu said is exactly right. If I'm outside the Earth and I'm on the moon and I'm taking a picture of the Earth, I'm only going to see a quarter of it at one time. And I've got to move through time in order to see all that, where the Dymaxion map takes those pictures of all the quarters and throws them right up and lets everybody see that. So moving to the center is important. And I hope everybody sees this octahedron. And of course, this is another view of the octahedron with a different perspective here. And I've actually got that thing. I have an animation of that thing, which I paid a lot of money for. Let's see if this is it.
Can I say something, Steve?
Yeah, do that while this thing starts to run, if it does. Go ahead, Manu.
Yes. Observing is inherently outside. Inherently. Feeling is inherently in. You're talking about the feeling here.
I'm actually talking about observing. I admit that feeling is part of the picture, but feeling is only one dimension. There are actually 7 dimensions in this model, but go ahead.
No, I'm just saying that, we're talking about it takes that context of in and out.
Right.
Get the whole stuff. Right? When you are in, you are talking about a gravitational field that make you understand everything around you.
Right on.
When you are out, you're talking about the mirror. You're talking about the relationally experience. That how is it divided? And you need both
Right.
to get the whole.
And do you see this guy inside this octahedron? That's exactly what's being expressed in the circles of irrelevancy. That guy inside the octahedron is this red circle.
Exact.
Inside this guy is non-conceptual finite withinness, too small to tune into it. There is a little edge of inside where I can close my eyes, breathe, and I can feel some sensation in my body. That's the twilight zone of almost irrelevant. With practice, one can actually move inside and experience more than just feeling. And the Buddha actually experienced bubbles, which is chromodynamics, which is quantum chromodynamics. It's the bubbles, it's the fluctuation in the quantum field that allows quarks to bubble out of that energy. When I look inside, I see the bubbles. So anyway, that in a way, this red circle represents the boundary of the octahedron on a 2-dimensional plane. I had another point that's minuscule. I won't bring it up because we like to keep moving, but I have a conversation about dimensionality, and I'll wait because I'm sure I'll have another opportunity to do that. Any other comments or questions?
The red is the visible that you showed on the electromagnetic spectrum.
Say that again, Manu.
I say the red circle that you
Hey,
showed.
the red.
That
That's a good.
is the visible on your electromagnetic spectrum.
I love that. And everything inside the circle is too big or too small, and everything outside the circle is too small or too big. Yeah, perfect. I like that. Thank you for connecting all my dots. Okay, any other comments or questions, or shall we continue? Let's continue, John.
Because humans want to see their whole Earth at once, cartographic projections of the Earth's surface were developed. Mercator, polyconic, polar azimuthal, etc. The Mercator became the most familiarly used. It is as yet found in 1980 to be the map most frequently used in schools around the world. On it, Greenland will often be seen to be larger than South America and North America, larger than Africa. It has no Antarctic continent, and the land on the left end of the map is seemingly 24,000 miles away from the land area on the right end, while in reality, these areas are actually adjacent. With only one exception, the fuller Dymaxion projection, all of the well-known methods of cartographic projection either chop the world data into a number of separately viewed parts or produce badly distorted images and continental fractionations. It was to provide a satisfactory means for humanity to see correctly the entire surface of the globe all at the same time that the Dymaxion sky-ocean projection was designed. With it, for the first time in history, humans can see their whole planet Earth's geography displayed on one flat surface without any visible distortion in shape or relative size of any of its data, and without any breaks in its continental contour. That is, the whole world surface is viewable simultaneously as one world island of unbroken contour in one world ocean.
Let's pause just for a
Dymaxion-
second. This
Yep.
is a diagram right here where he's showing how when a human being looks at a globe, they can only see 1/4 of it at a time. That's his thing. And obviously this guy's sitting in a very comfortable chair or couch. Okay, continue, John.
The Dymaxion transformational projection system that produces the sky-ocean world map divides the sphere into its maximum omnisymmetrical 12-vertexed 30 arc-edged subdivisions of 20 equicentral angled arcs of 63 degrees 26 minutes and 67 angles of 72 degrees each, spherical triangles. The 30 great circle arcs of 63 degrees 26 minutes act as constant peripheral integrity controls, preventing the breaking open and spilling out of the discrete data and distorting of the constant angular symmetry. Both central and surface during the transformation from spherical to planar display of the 20 triangles of the spherical and planar bound icosahedron. The more conventional projection systems that are widely used include the Mercator projection, the conic projection, and the polar azimuthal projection. All three of these systems gives rise to considerable visual distortion, which the Dymaxion projection avoids.
Okay, let's take a look at this. He says, include the Mercator projection figure 27. That's the Mercator projection. So what happens is the sphere is folded out into a cylinder, and because it's folded out into a cylinder, Iceland looks huge. So that's figure 27. Then the conic projection is figure 28. And so that's where we only see 1/4 of the surface of the Earth at any one given time. And then the polar azimuthal projection is figure 29, which again takes the sphere and expands it out into a two-dimensional plane. All three of these systems give rise to considerable visual distortion, which the Dymaxion projection avoids. And let's see if I can widen this out. And okay, so here are further ideas of different kind of spherical projection over here in 30. And the way he starts to view the thing in spherical triangles, and then takes those spherical triangles and projects them onto a two-dimensional plane. The result, I'm going to move ahead because I know it's down here, is this picture right here. And this is where John was pointing out that in the Dymaxion map, everything looks like one landmass, which it probably is, right? And
yeah, the other thing that it does in the context of John and Australia is that it immediately removes the myth of Australia being down under.
Yeah. Yeah.
Hello?
Instead of being down under, it's off to the left and down low.
That's right.
Okay. Hold on.
Go ahead, Manu.
Okay, just you see this?
Okay, let me stop the share so we can see this.
This is a Maxian map.
Yeah.
Yeah.
And then we saw in geometry that can be taught to kids easily that the most expanded of a finite system was what? What is the most expanded?
I don't know. I don't remember.
Is the icosahedron. We saw it.
Right.
Yeah.
We said the most compressed.
It's the closest thing
Or
to a
the
full
tetrahedron.
circle.
Yeah, we've been doing that all the time. The most compressed is the tetrahedron. Then he moves up to the octahedron. Then he moves up to the icosahedron or the rhombic dodecahedron. It's easy for kids to remember that. And the rhombic dodecahedron has how many faces? The icosahedron, how many faces?
20.
No, 20. Yeah.
As I said,
1, 2, 3, 4, 5.
Tw-
And then
tw-
alternate.
20 faces, 5 on
Yeah.
top and bottom and 10 around.
Yes. And that's what Bucky is simply what Bucky is saying there. And that's all he said. All of that, you know, if we really want to be, for the lay person to understand something of this geometry, is that a finite system can be compressed or expanded. And it has limits. It can be compressed down to a quadruple bonded tetrahedron. That's what it is.
Cool. This is the jitterbug when it gets
Yes.
compressed down
Yes.
to a four-bound tetrahedron. Think
Yes.
think the jitterbug
But,
and how
but
it ends up.
each edge of a tetrahedron is actually 4 bonds in
Right.
that.
In the smallest unit of the jitterbug.
Yes, yes.
Yeah.
Because you have a lot of rhombuses that compress into
Okay.
making that. And then it can expand to a maximum. That maximum is the icosahedron in volume. Is a maximum volume of a structured finite icosahedron,
Cool.
right? Is a maximum stable because you can go to the vector equilibrium, but it's not stable.
Right on.
Until you get
And
to
in
C60.
between those, there are only a few stable states, discrete. That is the octahedron, right? Basically. And that's all. Everything else that is above the octahedron is some kind of expression, is either the rhombic dodecahedron, which is an equivalent in terms of volume and energy to the icosahedron. And you see that you can undo the whole of this thing into a map. That's what Becky said.
Right on.
And that's all you teach your students. And that blows their mind. That's it. They don't need to go into the complicated mathematics. So to a lawyer, to whoever, you understand that systems are oscillatory. They are finite, they expand, and they contract. So what are your boundaries? If you are compressing a system, to what degree do you compress it before it collapses in? Right? And to what degree do you expand it before it ruptures? That's the dynamics of life. Right? We keep on doing these things.
That's the tensegrity of life.
Look at what I've done here. You see, I've done something wrong.
Yeah.
The color changes. They say, hey, this thing is not, I have to redo. Right?
Yeah.
I have to redo in a proper way.
So
That
Richard,
is fine. Look at this.
yeah.
That is the experiment of life. Yes, the smart guy scientifically will go about doing the mathematics, the wolframs of this world. But practically, this is what we need in life. We live in a finite system. We expand it, we contract it from time to time. And there are boundaries that are set. Those boundaries, some of them will respect some local integrity. How do we organize them in such a way that we have that local integrity? And you call that anti-entropic systems, anti-expansion, anti-radiative, anti-entropic.
Right on. Now, Richard snuck something into that argument there, or that conversation really quickly. Richard, did you say something about turtles?
No, I said tensegrity, but
Okay.
could have been turtle.
It could, well, listen, the Native Americans have the concept that the earth is a turtle.
Yeah.
And take a look at that turtle.
Oh, yeah.
And there, you know, if I were a Native American guy and I could not explain a tetrahedron or tensegrity, I'd say, look at the back of this turtle. That's why the earth is a turtle. you know? I just think that's really powerful. Here's another symbol of a turtle that's found in Native American, wherever that's
How
called.
many edges does a turtle have?
I don't know. You want to count them?
There are 6. I don't count anything.
Okay.
There are 6 ways the turtle visibly, in terms of structure, communicate energy to the outside or in between, whatever. You have the head, you have the forelegs and the tail.
Cool.
That's just to be fun.
So that's symbolic. That's symbolic of the 6 degrees of freedom, right?
Yes.
Yeah, I got it. Okay, cool. Any other comments or questions? Boy, what fun we're having tonight.
Yeah.
At least
well,
I'm having fun.
here's a fun one. When I spent 6 months in India, and I had to fly from Calgary to Mumbai, Bombay at the time. And if I could fly like the crow flies, I would fly north from Calgary to the North Pole and south to Bombay on a straight line almost, up and down. And then what direction would I fly if I was coming from Bombay to Calgary?
You go to Europe.
Yeah, right. No, this is as the crow flies. So it would be the same direction. I'd fly north from Bombay to the North Pole and then south to Calgary.
Yep.
Exactly the same direction,
Cool.
both ways.
It doesn't make any sense, does it? To get there, I fly north and south, and to get back, I fly north and south.
Yeah.
Yeah. Very cool. Cool. Any other comments or questions? Well, we're approaching the end here, and probably I'm looking at our reading. I think it's probably a good place to stop. He starts talking about in 1964, the United States Information Agency asked me to consider a design for building an exhibition that might be adopted. So rather than get into that, we'll go ahead and pause right now. Well, John, thanks for reading tonight. How are you feeling, and do you have any takeaways tonight?
Yes, I'm feeling good. Always enjoyed playing with tetrahedra and being reminded of the building blocks of the universe. And some interesting issues have come up, thought-provoking. So I go away with things to think about. I love the icosahedron and the Dymaxion map. I've actually got a couple of them in my office, and I remember being introduced to it. In fact, I've got one on the wall here. I'll just go for a little walk actually and see if I can find one. We might actually be able to find one. Ah, there we go.
Yes, there it is. Yeah. John, you used to be the only one with it, and we used to kind of, envy you.
The headline on that map, John, the headline in that map was Global Energy Network. Is that what it was?
That's right. That was something that Peter Meissen developed out of Bucky's work. Peter Meissen's an American engineer who became exposed to Bucky's work in the 1980s, and he established the Global Energy Network, which is still functioning. It's recognised by the UN as an NGO, a non-government organisation, and it's been a driving force for renewable energy and the reduction of pollution from traditional energy sources for well over 30 years now. So Peter's a friend, visited us in Australia in the 90s. So yes, look at Geni, G-E-N-I. Go on to the internet and look for geni.org, and you'll find a lot of interesting Bucky material and some interesting information about what we need to contribute to a better world, a more sustainable world.
And Peter was the person who organized and hosted the 100 years birthday party for Bucky in 1995 in San Diego.
My wife and I were there.
Then I was there too, so you and I must have met.
Yeah.
My favorites were going to a workshop with Amy Edmondson.
Yes, yes, I remember Amy.
Meeting Allegra.
Yes.
Meeting Anwar Dill,
Mm.
who wrote almost the last book with Fuller called Humans and Universe. And it was the one textbook I took with me to India and read it quite frequently. Oh, wow. So
Now you've
That's
stirred up a
amazing.
lot of memories, Richard.
so there we were, you and I together in San Diego, celebrating Bucky's 100th birthday.
Mm.
Wow. I'm totally impressed at what a small world this is.
Yeah.
Can you spell the name Peter Mason in the chat, John?
In the chat,
Can I do
Yeah.
what?
Just spell the name Peter Mason.
Oh, Meissen. Yes, okay. So
Meisen.
yeah, Meisen, and it's genie.org. So go and look for.
Okay.
Wow.
Mm. Yep. Anyway, so
And
I'm
John, you
I'm
came
feeling
all the way
great.
over from Western Australia just for the party that weekend.
Yep, that's right. Yep.
And I learned about it quite late in the advertising. I said to my wife, I'm going to San Diego on the weekend. If you want to come, you can. If not, I'm going anyway.
and you stayed married?
Yeah.
Good for you.
Anyway, I don't.
This year is number 60.
Well done. That's quite a milestone, Richard. Well done. Anyway, great to be here. And as I say, I've got lots of things going on in my head at the moment, so I won't be here. I'm an apology for next Sunday. But Manu, how do you feel? What do you take out of today?
Well, I'm feeling good. You know, it's a nice day here. You know, Cape Town has been now kind of what you call the fair Cape. Not too windy, sun, but not too warm. It's just nice these days. I don't know for how long we're gonna keep it, but it's like that. It's good, and really it got me on the good foot this morning. The other thing that is important here is that I admire so much Bucky to taking out the complexity of concepts and putting them in a way that a lay person can understand and actually apply them. And that is not a small feat. And truth is that it is so comprehensive that we still today struggling to understand the fullness of them. Right?
Mm.
So I'm just really grateful to that man. And I'm grateful to all the souls that are here today, that have been here, and that are committed to really helping us understanding, helping us expand on them, helping us enrich them, and helping us really apply them more in life. And that is my best takeaway, is that it is at, you know, everybody can understand this, to be truthful, if we really put ourselves in a baby's position. That is to remove all of the weight of the conditioning that we have, and that's not small feat, and be able to just try to grasp what is going on here. And that's my biggest takeaway. Otherwise, I'm grateful and I'm thankful. Joe, how do you feel? What do you take away?
I feel fortunate. I apologize. I was a little bit late there, but still had a lot of great takeaways. I really enjoyed, you know, kind of the few passages that we went through and the discussion overall. You know, for me, I really liked where you were talking about expanding the boundaries, you know, specifically, and how when we're expanding our boundaries, we're seeing new relationships. And I think that that's something that, for me, it represents a lot. It represents something about you're not stagnant, you're not dogmatic, you're not seeing the world from one perspective. And that's very powerful. And we went over even the 7 directions that where you would have different viewpoints of the world. And I think that there's an interrelationship there. Sometimes we can get very narrow in our perspectives, and it can cause a lot of problems. And it's interesting, and just from another perspective, you know, they were using this week a number of generative AI tools, all in a very, very narrow way. All of them were kind of missing the whole to a certain degree. So which actually limits the tool itself. And it's no different than actually if the type of data that they would take in, it would do one task and that's it. And I felt like, wow, that's almost like a specialized AI or something along those lines, with a very narrow perspective on the world, not necessarily incorporating the whole. Not that, you know, but it was just interesting to witness, because they were all different companies too. And you know, I appreciate going over the Dymaxion map as well. It provides perspective, and I think that that's I never get tired of looking at that, because you know, I've looked at a globe, I've looked at a sphere my entire life, and now that I truly understand what is seen and unseen, you know, that has you know, that has changed the way that I approach things, not by itself. I always believed in generalized principles, but I have a deeper appreciation for generalized principles because of that. And so, yeah, I think that all the most expanded circle we're taught in school, it's the icosahedron. And that is true. So anyway, I was very fortunate to be here with everyone this evening, and I very much appreciate time. My apologies for my tardiness. I had to make a journey back to the doctors and get checked out. So, but we're home and it's good. So, Richard, how are you? How do you feel, and what are you taking away from today?
Well, I feel very good. Very warm and balmy in Maui. My apologies for the video camera not working. It's my old computer that I brought with me. These last few weeks have been a whole series of connections, new connections with people that have been part of our training system, reconnections with many that I haven't seen for a long time, both in a long weekend conference in St. John's, Newfoundland, then again in Calgary, Alberta, and then for tonight to have a different kind of reconnection, in realizing that that John and I both attended Bucky's 100th anniversary celebration in San Diego in 1995. That really is quite remarkable. And one of my co-founders of my organization, a psychiatrist, he moved to Perth in the 90s and spent a good long time there, and he's just recently come back to Canada. But so all kinds of interesting connections. So I value our time. I value the opportunity to discuss Fuller's work in a way that I've never, ever been able to do throughout my career. I was usually, to some extent, all alone as a bit of a maverick, trying to do the kinds of things that John has done on his logo, convince people that there was something valuable in understanding things through the lens or the faces of a tetrahedron. For many people, all it did was sort of create glassy eyes sometimes rolled eyes. But so to be connected with this group and the Trintab group that I meet with every 2 weeks, and a group called World Weavers, plus the 52 Living Ideas, I couldn't ask for a better sort of network of people to do the kinds of discussions that we've done tonight and we do every week when we meet. So thank you all, and I go back to Steve. And how are you feeling? And what's the evening coming out for you?
Really good. Thank you. Manu, did we get you so far? Did you give
Yes.
your
Yeah.
takeaway?
Yes.
All right, good.
Yes, have been, yes.
All right, good. Well, thank you, Richard, for staying awake. I've been so captured in everything I've gotten from this. I haven't stayed as organized as I'd like to stay. I just, as another epiphany or challenge today, I want you all to know that I have taken this diagram right here with a circle in it, and I've created a new diagram with the edges of the octahedron in it. So,
Beautiful.
so that's exciting to me, and I'm so grateful for Manu pointing that out to me. Duh, right? That when I'm inside there, I'm in the octahedron. And I said it, but I didn't hear myself, and Manu was kind enough to bring it out. Wow. To me, this conversation is all about the topology of being a human being, not just how tall am I, how smart am I, how dumb am I, what did I do yesterday, but what is my potential? As I take a look at the fact that the universe is energy, that the globe is energy, and I'm this observer somehow in a micro perspective, in a local perspective, looking at something much more huge than myself, huge on the outside and huge on the inside. In fact, I've invented a word. The word expansion is often used, and to look inside, I've used the word inspansion, because it's not just a matter of out and in, or expansion and contraction. It's expansion and inspansion. As it expands, it goes out and out and out. As it inspans, it goes out and out and out from the inside, like a giant hourglass. Expansion up here, inspansion down below. All the raisins are getting further and further and further apart. There's more and more space between realities, and there's more entropy, and so there's more possibilities. And just understanding these principles are just really profound to me. And I'm just really grateful for that everybody's willing to play here, because I drive people crazy. I feel like Richard, Of course, Richard, you've been frustrated for 50 years. John, you've been frustrated for 40 years, right? You guys have had this perspective and have tried to implement it in your business. And I'm just catching up with you guys. I'm so grateful for everybody sharing. And Joe, that you, with all the stuff you have going on, that you were able to show up tonight is wonderful. And Anne gave us a text when she had to leave. She put in the chat around 10:40. It'd been great to hear from her. And we started the takeaways. I should have started with her, and that way she would have been able to share. And so, she'll be back in 2 weeks. You guys are the best. I'm open for any feedback or input anytime, and grateful for the insights and outsights, things like that I'm getting these days with you all. So thank you very much.
Thanks, Manu. Thanks, Joe. Thanks, Richard.
Thanks, everybody. It's almost 1:00, almost perfectly 1:00 there.
Okay.
And Richard, by the way,
Go to sleep, Joe. Go to sleep. Catch.
Yeah,
Yes.
no, I got another call. I got one more call.
wow.
So,
Really?
And Richard, in my book, I've gone from observer to chooser. Because that becomes the participant. It isn't just enough to observe the universe. I get to choose. I have choices.
Yes.
Then
yes.
that leads to a discussion of free will, and that's another conversation altogether. It's a technical conversation. So I am a chooser nonetheless, whether I have free will or not. Thank you all.
Bye now. Yeah.
John, John's gone. Okay, good. Bye, everybody.
take care.
Wow, what a group.
Excellent. Cheers.
Bye-bye.